Hi everyone, Mr. Neff here. This is the History of Forces video 1, and it's going to cover some of the ancient stuff, and you might think, oh man, why do we have to do this? But this is very, very important. Even though this stuff is some ancient stuff, this is the root of some of those misconceptions that you had in that force concept inventory. And so understanding some of the history of it will really help you going forward. So please take this seriously. It will serve you well. So we are in this new unit now, and this new unit spans chapters 4 and 5, and that's Newton's laws, and then circular motion. How does the uniform circular motion happen? What causes that? It's going to be about the causes this time, and that's a new thing for us. So far we've been talking mechanics, but all the mechanics that we've done has been kinematics. And remember, kinematics is the describing of the motion, not talking about the causes of motion. Dynamics, on the other hand, talks about the causes of the motion. And so when we're done talking about this, you'll not just be able to predict what it's going to do or say what it did in the past, but you'll be able to say why it's doing this. Now, this history talk is mostly about ancient scientists, but they're not all ancient. See, we are going to start with a very modern scientist, no longer with us, unfortunately, but a very modern scientist named Thomas Kuhn, who he grew up in eastern Ohio, not far from here, and he ended up doing his work at Cal Berkeley. Well, he was a philosopher and a scientist, and he said that science doesn't progress in a linear way. Instead, it undergoes these paradigm shifts. Now, a paradigm is a way of thinking or doing something. We all have a ton of paradigms for everything we do. A paradigm shift, then, is a change in that. And it makes me think of a picture like this. You know, we've got a picture on the left, and you look at that and you see an animal. You say, I see rabbit, or you say I see a duck, and you might look at that and you might say rabbit, 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 and you might look at that for a long time, and then all of a sudden it just pops out and says, oh, that actually is a duck too. And so it's a different way of seeing the same thing. So you were looking at it one way, and then all of a sudden you say, it dawned on me, I never noticed this part before. Maybe science is going to do that same thing in your lifetime. Sometimes Thomas Kuhn says science goes down the wrong road sometimes. And that's where the analogy breaks down. But he says sometimes science goes down the wrong road, and then all of a sudden, we realize, hey, we were going down the wrong road, and we go in a different direction rather than just progressing in a linear way. Sometimes technology is going to improve, and that's going to bring science along with it. And here's what I mean. If you look at a picture like this one on the right and you look at it from far away, you might say, that's a skull. But maybe technology improves and it allows you to zoom in. Maybe you have a better telescope, a better microscope, a better way of thinking, and all of a sudden you see that it's a ship. And so all that to say, science is going to undergo these paradigm shifts rather than just getting closer and closer and closer to the end goal. And the paradigm shift that I want to talk about is the paradigm shift of what's at the center of, well, historically, the universe. Today, we'll say the solar system. And for most of our existence, most of the time we've been thinking about the heavens, we've been thinking that the Earth was the center. You say, well, wait a minute, I don't think that. Well, I said most of the time. From the beginning of astronomical thought, whenever that was, all the way through the 1500s, people thought that the Earth was the center of the universe. And you might say, oh, that's great, but what does that have to do with our talk of forces? Well, everything, it turns out. It turns out that everything. Back in 384 to 322 BC, we had the first physicist. We had Aristotle. And you might say Aristotle's physics was a little shaky. Well, everybody's physics is a little shaky until it's built upon. And so Aristotle is credited with getting us going down the road of physics. And Aristotle had this system, today we call it Aristotelian physics, and he thought that everything was made up of elements. And you and I think that everything is made up of elements too. And that's in the study of chemistry. Aristotle had different elements than we do, maybe primitive, maybe you'd laugh at the elements, but the idea that things are made of particular elements is a pretty good idea. Now, you might say, okay, that's great, but that's chemistry. Well, they were very, very closely linked and still are today. See, Aristotle thought that those elements were in an order, and that order was really what drives motion. So Aristotle thought that we had this universe of order, and there was a hierarchy, and you'll see that on the next slide. See, you and I don't think that that's true. If there were a fall day and you came upon a pile of leaves like this, you would say, that didn't just happen. Could the leaves have fallen there? I guess maybe, but that's just never what happens. If you see this, you know that somebody intervened. You know that somebody did this. Well, instead, what happens is randomness, chaos, disorder, entropy, if you like. Here, what happens in real life is the leaves are going to fall everywhere. They're not just going to fall in one nice pile like that. Well, Aristotle thought a similar thing. He thought that every element had a natural place. There was a natural order. I kind of make it funny and I say that everything had a home. And so it was a vertical hierarchy. And the earth was the lowest element. That means lowest down, not like bad, but the lowest down. And then water was right above that, and air was above that, and fire was above that. He said you can see that all around. You can see the earth is at the bottom, and then right above the earth will be, if there is water, it'll be laying on top like a lake or a river or a puddle. Air is on top of that. And the fire one, maybe you say, well, that's a little bit weird. And no, he's not talking about the stars and the sun. He's just saying that, that there must be something up there because hot things do rise. And so all that to say, he said that this is what is going to lead to motion. This order and the restoring of that order is going to lead to motion. And he said that we have these natural motions, and that's motion that restores that natural order. And he said that it'll happen on its own. So you have a thing like a campfire with smoke rising, and smoke, he would say, is a combination of air and fire, and it's going up. And why wouldn't it go up? It doesn't belong down there on the earth. It belongs up. And we have rain coming down, and somehow water gets into the air, and it's going to come back down because that's where it belongs. And then here he wouldn't have this, but here we have some carbonated drink, and the bubbles are going to go up, and he would say, well, they're going up because where do you expect them to go? They're going home. That's where they belong. Point of all of this is that Aristotle would have said that these natural motions occur without any force. He didn't use the word force, but he meant it. He would talk about things like interventions and things like that. He was really talking about a force, and he says you don't need a force to make this stuff happen. Now, in contrast to that, he said that there are the other kinds of motions, and he called them violent motions. Now, the violent motions are the ones where an outside influence, you and I call that an outside force, acts. Now, you remember from elementary and middle school, they used to define a force as a push or a pull. And in fact, when we were doing vectors a few weeks ago, I did too. Today, I want to say a little better thing about that. I want to say it's something capable of changing an object's state of motion, or changing its velocity, or accelerating it. So Aristotle would have looked at all of these things and said, this stuff is violent motion because you need forces to make this happen, and all of it is moving things out of the natural order. These weights, that's not where they belong. This tree, that's not where it belongs. This horse is going to pull this cart, and you can make that happen, and it's not going to happen on its own. The cart's not going to roll on its own. Why not? Because there's no benefit to going over there. It's all where it is just as good in terms of going home as where it will end up. And so that's where, if you want that to happen, fine, you have to make that happen. Sometimes people think that if a bear or something from nature does it, it would be natural motion. That's not what Aristotle meant. He said if you're a bear and you lift this rock up, well, it doesn't belong up there. It's made out of earth, and it's going to fall back down. Now, the important point behind all of this is that these motions would only occur if something pushed them, only if there was a force to make these things happen. Okay? Now, and one thing that's kind of neat though, and Aristotle recognized that his theory couldn't explain this, is something like an arrow. Now, she's going to launch that arrow, and that arrow is going to start to move forward, and we can understand why it moves forward while it's being pushed by the bowstring. Well, there was a force on it. He said he didn't call it a force, but he would have said, well, there's violent motion. But then what about the instant when it's out of the bow and it's here? Now, we just went through projectile motion. We know what that thing does. It's going to follow that parabolic path like this, you see. It's going to fall, and of course it would fall, says Aristotle, it's going home. But here's the thing. Why do things like arrows, rocks, balls, whatever, why do they keep moving forward with constant speed? Why do they do that? And that would be something that he would say, I don't know, because just like this wagon had no benefit to go forward, so you'd have to make it go forward, why does the arrow continue to move forward? See? Why does the arrow continue to move forward? And I wrote on it already, but why does the arrow move forward? Well, Aristotle doesn't really have a good explanation with that. And how does this tie in with the Earth being the center of the universe? Well, here's the thing. If Aristotle's right and you need a force or you need something to make something move out of its natural place, then that means the Earth has to be the center, because what's the Earth made out of? Earth. Where does Earth belong? Right where the Earth is. And so the Earth has to be the center, and the other things have to be going around, because what's big enough to move the Earth? Certainly not that little bitty sun, which, remember, back in those days, they didn't realize how big that is. That little bitty sun isn't going to be able to move the Earth around. No. And so all that to say, the Earth's got to be in the center. It's where it belongs.